problem 2, it gives us the coordinates of 4, 3, and it says, if that's the case, tell us what the sine of theta is and what's the cosine of theta. So let's just think of this on our axes. So here's our x-axis, here's our y-axis. We've gone over 4, so I've gone over 4 units, and then I've gone up 3. So right here's the point we're talking about. There's the corner point. And it wants to know the sine, and theta is always going to be right here with our x-axis and the line that's formed. It wants us, in this case, to say what is the sine of theta. Well, if we just make this the triangle right here, within basically the circle. So here's the point, the circle could be going something like that. Doesn't matter. Here's theta. That's where it's going to be. Well, let's think. If from here to here is 4, this leg is 4, that length is 4, it's gone up a height of what? 3. Well, if you have a triangle, now this is going to be a right triangle, with a leg of 3 and a leg of 4, how can you find this hypotenuse? Oh, Pythagorean theorem. Well, we should recognize a 3, 4, 5 triangle. That's a common triangle that everybody should recognize. It's a Pythagorean triple, and it's the most common of any we have, a 3, 4, 5. If you don't believe me, look, a squared plus b squared is going to equal c squared. 9 and 16 is 25. 25c squared, c's got to be a 5. So there's the Pythagorean theorem done for you. You can see it's a 5. Now, it says, what is the sine of theta? The sine of theta, well, what is sine? Sine is, remember some old hippie called another hippie tripping on acid. Remember that? Sine is your opposite, which is 3, over your hypotenuse, which is 5. So it's 3 opposite over hypotenuse 5. Cosine is your adjacent side over your hypotenuse. My adjacent is 4 over my hypotenuse of 5. And there you have the sine of theta and the cosine of theta when you're dealing with the coordinate 4, 3. Always just make your right triangle right in the distance, figure out your hypotenuse, and then you simply go to the SOHCAHTOA piece. Problem 2.